Okay, here's the second problem in our list, and we have a box sliding to the right, and there is friction. It's being pulled by some kind of tension. 100 newtons at 27 degrees above the horizontal. It says determine the value of mu k if the box is sliding with a constant velocity, and that's one thing we should definitely underline. It says constant velocity, which means there is zero acceleration. All forces cancel out. And the first thing that you should do if you're stuck, or if you're going to do a problem in the first place, is draw a free body diagram. And one reliable force is going to be the force of gravity. It's going to go straight down, and I'll just write down Fg for that. The other force here, obviously, is going to be tension going up and to the right. I'm going to line my ruler up, and that's going to go up and to the right. And we know that that tension is 100 newtons. Another force here would be normal force, and that's going to go straight up. And we're not sure how big that is, but we're just going to draw it straight up. And we need a force that's going to the left, because we don't want this thing accelerating. That force to the left is going to be our friction. And I'll just label that as the force of friction, Fr. Sometimes you'll see me do it as F mu, but right now we'll just use FFR. So looking at all this, we have a two-dimensional problem. And so I'm going to go ahead and draw the components of my tension force here. One goes to the right and one goes up. And we know that this angle is 27 degrees. And we can find these pieces. So let's find the piece over here. And the piece over here is going to be opposite my 27 degrees. So we have opposite, we have the hypotenuse here. OH is going to be sine. So this side is going to be 100 times the sine of 27 degrees. This side is going to be the adjacent side. It's going to be 100 times the cosine of 27 degrees. And while we're at it, a force of gravity is mass times the acceleration due to gravity, g. And it's 20 for the mass. Let's use 10 for gravity, or acceleration due to gravity, so it's going to be 200 newtons downwards. And that's about all we can find out right now. One thing that I might want to write out in the beginning is that we have the force of friction. And I know that the equation for the force of friction is going to be normal force times my coefficient of friction mu. And that's actually what we're looking for, so that's good that we have that. And so we'll take it and we will talk about the sum of all forces in the x and the sum of all forces in the y. And so starting off with the x, we know that the sum of all forces should be equal to 0, because we don't want it to accelerate. It's constant velocity. And what things are in the x? I see two things. It's going to be the x component of this tension and the friction. So we'll say we have 100 times the cosine of 27, going to the right, and we have this force of friction that's going to the left. That's pretty much all we can do right there. I guess one more thing could be, we can just rewrite it, cosine of 27 minus the force friction's equation, which is actually normal force times mu, and this is going to be equal to 0. So we want mu. We don't have normal force. If we had it, then we can just solve it immediately. But right now we're stuck there, so we're just going to leave it and come back to it later. Going to the y direction, we have the sum of all forces equaling 0. And we have three forces going in the y direction. We have gravity, 200. We have the 100 sine 27, this component of tension. And we have normal force. And so we're going to say, hey, normal force is positive. It's going up. And we're going to say plus 100 sine of 27. And we'll do minus 200. And that's going to be equal to 0. So we have one missing thing there. That's normal force. And if I were to solve this, I can say normal force is equal to 200 minus 100, the sine of 27. And this should make sense to us, because if the tension wasn't there, normal force and gravity would be the exact same number. But since tension is pulling up, normal force from the surface, the force that the surface is pushing back up on this box doesn't have to be as high, because tension is helping it out. And so 200 minus 100 times the sine of 27 gives me 154.6. newtons. So without this tension pulling up, the normal force would be 200. Here we have tension helping us out. We get 154.6. That normal force is going to go straight in there. And so let me just do 100 times the cosine of 27. And that's going to give me 89.1 minus the normal force, which is 154.6, multiplied by mu, k, that's kinetic friction's coefficient, and that equals 0. And we can solve that. So 89.1 is equal to 154.6 times mu k. And the last thing to do would be to divide 89.1 by 154.6, and that'll give us a nice decimal for mu k. The mu's are always going to be decimals, pretty much. It's very rare that it's greater than 1. Glue. I don't even know if you can consider that a mu. But 89.1 divided by 154.6 gives me a mu value of 0.5763. Sure. And so mu k for this problem is equal to 0.5763, and there are no units for mu. There you go.